and virtual also. But today is a webinar because we're having a special guest speaker, Mr. Ricky from Germany. Thank you for coming, everyone. I would like to also welcome to this forum all our past presidents, fellows of NAPE. I'm trying to see if I can get some of us online. Okay, I can see this is Doris Akpogwea, one of our past executives online, and also our present executives. I could see our VP, Mr. Hibazoye online also. I also am seeing coordinators of chapters attending this meeting this morning. I also want to appreciate the media section of the NAPE Abuja National for putting these virtual meetings together. Thank you so much, Mr. Tunde, for this for putting this beautiful virtual meeting together. Also welcoming chairman for today, Mr. Olatomiwa Olani. In just season will be introduced by one of our executives. Thank you for coming. And today is actually a special meeting, and the topic for today's meeting is understanding machine learning for geosciences in the age of artificial intelligence. It's actually a great one because in this age of artificial intelligence, machine learning is not just an opportunity, but it's a necessity for advancing of our geoscientific knowledge and safeguarding our environment. And it's also enhance our practice as geologists and it's also in the oil industry. Thank you for coming. At this junction, I would like to invite one of our executives, Dr. Mariam, to introduce the chairman of this occasion of this meeting. Dr. Mariam Shehu, over to you.
All right, thank you very much, Ma. I'd like to welcome each and every one of you and sit on the existing protocols, right? Permit me to introduce you to our chairman for this technical meeting, Mr. Olatomiwa Olani James. Mr. Olatomiwa has over 26 years of experience in the oil and gas industry, focusing on upstream operations, research, and innovations. He graduated from the Federal University of Technology, Mina, with a BTech in geology in 1992, and obtained a master's degree in applied geophysics from the University of Ilorin in 1998. He began his career at Nigerian Ajib Oil Company in 1998 as a well site operation geologist and joined NNPC in 2005 as supervisor operation geologist at NPDC Benin. He progressed to being the deputy manager, geology and geophysicist, then to manager of NAOC assets, OML 60, 61, 62, and 63, achieving the record oil and gas production in 2020. Later, Mr. Olatomiwa became the manager exploration JV operations at NAPIMS in Lagos, overseeing all JV assets exploration activities. He was then transferred to NNPC's Research, Technology and Innovation Division in Abuja, where he served as the Deputy Director, Upstream Innovations. He is currently the Director, Head of Innovation-Led Research at NNPC RTI, where he is responsible for research and innovation initiatives aligned with the organizational goals. He is a certified innovation professional, innovation officer, and a member of NAPE, NMGS, SPE, and AAPG. Please join me to welcome our chairman of this technical session once again, Mr. Olatomiwa Olani James. Thank you.
Thank you so much. So Mr. Olani, over to you.
Okay, good morning, everyone. I want to welcome everybody. Yeah, good morning. I want to welcome everybody to this technical meeting. First of all, I want to thank our guests for today, our past president and the fellow president and the president-elect. Also, I want to thank the NAPE Abuja chapter team for this opportunity. The topic for today is very, very resonant with where we are going as a geoscientist. Understanding machine learning for geoscience in the age of AI is very, very crucial to us, especially as a geoscientist. Whether in our industry, if you look at what we do, seismic interpretation, seismic processing, well logging, for us to enhance accuracy of what we do, I think machine learning and AI is going to help us a lot. It's going to give us speed, going to save our time, and accuracy of our data too. So, but I don't want to go deep. First of all, I want to also welcome our guest speaker, Mr. Sambo Macharm. Briefly, I'll just go through his resume so I will know that it's loaded with a lot of stuff. And I want to encourage us to listen attentively. All our question and answer will be on our question and answer section. At the end of his presentation, we're going to take maybe 2 or 3 questions. And then if there's any other thing, we allow maybe our past president to say 1 or 2 things before we end this program. Madam, can you please just show the agenda for this meeting so that everybody can be aware of what we have in store for today?
Okay. We'll do that. Mr. Tunde from the media, they'll do that. I think we are going to introduce the speaker.
Yes, no, I know I will do that, but it's better to flash the agenda so that everyone will know where we are going. It's better.
Okay, no problem.
Okay, so if you look at the agenda, we are on 11:20 to 11:22 introduction of the speaker, which I'm going to do now. Then after that, the speaker, Sambo Macharm, is going to go into his presentation. Then after that, we are going to panel review and thoughts at this question and answer. Then after that, we'll do question and answer. Then next is presentation award. Then after that, we're going to do announcement of NAPE activity for Abuja chapter. Then we'll do vote of thanks. So now I think I need to let me go and introduce the speaker to all of us. Our speaker today is Mr. Sambo Macharm. He's a data scientist based in Abuja near Frankfurt, Germany. He holds a Bachelor of Engineering in Electrical and Electronics Engineering from Abuja University, Bauchi, a Master of Science in Financial Engineering from Washington University, Illinois in USA, and a certificate in Python for algorithm trading from Sambo University of Applied Science in Germany. Ricky has a diverse professional background, starting as an electrical engineer at the Jos Metropolitan Development Board, and later leading an engineering team at the National Veterinary Research Institute in Bonn. Transition to data science, he has a freelance consultant. He has been a freelance consultant since 2018, specializing in AI tools for predictive analytics and infrastructure maintenance. He has also significant contributed to machine translating project for low resource African languages. Ricky is skilled in Python and various data science technologies, and is committed to mentoring others, having trained over 20,000 individuals in data science. His work is exploratory project and consultancy, including notable projects in Ethiopia, underscore dedication to delivery data science for empathic solution. So on behalf of Abuja NAPE chapter, I welcome Mr. Sambo Macharm. You are welcome.
Hello, everyone.
Our speaker, yes. Hello.
Hi, Ricky.
Hello, Mr. Ricky. Good to see you today.
Can you hear me?
Yeah.
Good to see you.
Yes, we can hear you.
Okay, so my turn now to start talking. Hello?
Yes, sir, you can go ahead.
Oh, okay. Yeah, I just wanted to be sure I wasn't jumping. All right, let me just share my screen. Can you see my screen, my presentation?
Not yet.
Not yet, please.
All right, sorry. There has to be some mixed up in my controls. Let me reshare again.
Okay.
So I guess we can.
Yes, I can see your screen now.
Yeah, we can see.
Okay. I want to thank all the officials of NAPE. I want to thank the chairman. I want to thank Dr. Eunice and the past president and all the officials of NAPE for inviting me to give this presentation. I've been introduced already, so I'll just get on with the talk. So I tagged this understanding machine learning for geosciences in the age of AI. And I am not a geoscientist by any means. I have been an electrical engineer, like you've heard. I've moved across quite a number of domains before I settled for machine learning. And I just want to let you know that machine learning is like a hammer. We need people who understand what they want to do. You can use a hammer or a mallet to chisel things off. If you maybe you want to sculpt something out, or you want to produce some form of carpentry work of art or something, whatever it is. So there are different skills you need. So machine learning can work with anyone. You can work with artists, you can work with doctors, you can work with geoscientists, you can work with petroleum engineers, you can work with a variety of other fields. So just like a tool. What we emphasize in machine learning when we train our students, we try to tell them that you need to have something called domain knowledge or domain expertise. And we believe that with machine learning, if you learn it as a tool, you'll be able to apply it in different domains. With that being said, let us understand what is machine learning. Machine learning has been the field of artificial intelligence. It enables computers to learn from data and improve their performance over time without being explicitly programmed. What does that last line mean? In the past, for you to program, we still do it today. You have to tell the computer, go this way, go left, go right. If you move 10 centimeters, stop, turn left and see, or do this and do that and do that. So you're explicitly telling the computer what to do. So if you have a group of shells, you have to describe the shells in detail. If you try it, the computer doesn't understand, you have to do it again until the computer understands. Then you now tell it, okay, these are shells, these are maybe dirt you got from the seashore, whatever it is. You want to describe houses, you have to explicitly write the code that tells the computer what a house is, if the computer understands. But with machine learning now, the computer sees all that data and makes sense out of it. So normally for machine learning, we'll try to give it stuff that has to do with numbers, usually. So you have to tell it, okay, it doesn't have to know whether if it's 50 degrees above that or 15 centimeters below that, this should be that. It sees the pattern and tries to bring some meaningful output out of it. We have maybe broad strokes, maybe 3 kinds of machine learning. You can go deeper, but I'm just introducing it on a high level. We have what we call supervised machine learning. This is a type of machine learning where the model is trained on labeled data. What do we mean? If you have some kind of data you're presenting, you have to tell the machine, this is what this is. Then you give it different inputs that look like this. Then you introduce maybe a different color of this and see if the machine was properly trained. So it's like when you were students, you were taught some things in class, and then the lecturer tries to bring something else that you haven't seen, but not too far away from what you've seen, so that you can, to see whether you can make the leap from what you were taught in class to what is being presented to you in the test or the exam. It's the same thing we do with computers. So supervised learning is you show it the answer first, you show it the pattern, then you show it the answer, what you expect. Then it's supposed to look for a relationship between the features you're giving it and what result it expects or you expect for it to bring out. And then as it does that back and forth, it should be able to come up with a pattern so that anytime you give you something it hasn't seen before, you should be able to make that jump. Then we have the unsupervised machine learning where it goes in, finds a pattern and presents to you what it has seen. You may not even know what it is looking for. You don't even know, it doesn't know. It just goes through it. And then whatever pattern it sees, it can separate it for you. This is one technique. Another one we call is reinforcement learning. It's a type of machine learning where an agent learns to make decisions by performing actions and receiving feedback in the form of rewards or penalties. This is still growing. It's not been used in big places yet, but some people are trying to use it in different forms. Like I know my professor in Germany here is trying to use it to see if it can trade on his behalf. And that's what he seems to be, focusing on the last few months. I was in touch with him. Now, before machine learning, we had statistics. Actually, most people call machine learning statistical learning. So we know what statistics, is, or yeah. So traditional statistics has to do with hypothesis testing, regression analysis, probability distributions, inferential statistics to draw conclusions, and all of that. We did most of this in school. From secondary, I think we did the line of best fit, which is, I'm going to show us a bit of a detail in here. And it's been used for scientific research, business analytics, and many other fields. Now, then machine learning came along, and this is like pushing the envelope. Machine learning builds on the principles of statistics, but takes data analysis to a new level by leveraging computational power and algorithms to automatically learn patterns from data. So the idea about machine learning, as we can see, is to learn patterns from data. Computers have popularized machine learning by providing the computational power and storage required to efficiently process large data sets and run complex algorithms. There's a company now called NVIDIA. They started, okay, let's make chips. And they were wondering, okay, there are other companies who have been making chips in the past. What chips are we going to make? Who are going to be who are the people who are going to concentrate on? And they decided to concentrate on gamers. And they started developing chips that were specific for gamers, whereby you can see all the 3D effects, you can render all the videos as clear as you can, and you can, play around with it. Then eventually, I think sometime in the 90s, they decided to pivot into machine learning, which was struggling because it needed something fast. So they had to create something called GPU. It's called graphical processing unit. We had the CPU, which was the central processing unit that we've been used to since the 70s and all that. So then I introduced something called GPU, where graphics are being rendered quickly so that the avatars you're turning to shoot or whatever games you're playing can move, almost like it looks realistic. Some of the games you see when people who are in shots and such things are playing them, they look very nice. So that was what kind of brought them out. And a few months or a few weeks ago, they were even the most valuable company on the NASDAQ, the stock exchange in the US. And so it's competing right now. I mean, a few years ago, it was nowhere close to the first 5. Now it's the first 3, and it even went above all of them before. I don't know where it is right now, but when you look at their names, you see Apple, you see Microsoft, and you see NVIDIA. These 3, one is leading. I think probably Microsoft is a leader right now, but NVIDIA is there with them because everybody's going to AI, and which we'll try and talk about much later. So we'll just talk about linear regression, which, like I said, we all know. In the simplest terms, it's a statistical method used to predict or explain the relationship between two variables. So we're going to give an example. So what we say is that one variable is considered a predictor or independent variable, and we call that X. And the other is the outcome or dependent variable, and we'll call that Y. We'll get into that in a little bit. Linear regression tries to find the best straight line that fits through the data points of these two variables. So the idea is you predict the value of Y or estimate the value of Y if you are given the value of X. So another thing is to understand how much Y changes when X changes. Let me just keep that. So let's talk about two different domains. Some people measure temperature in Fahrenheit, while some measure temperature in centigrade. I think it was in the 70s that we switched to the I think the SI units, we switched to international unit, and which was good for us because it was easier, everything was base 10, and so on and so forth. Fahrenheit is quite confusing, but some people still use it. I think even in Nigeria, while I was working with the National Veterinary Research Institute, when they are measuring the temperature of eggs and all that, when you want to hatch them, I don't know why they retained the Fahrenheit forms of reading. But there are things right off the bat that we can see that we know about the Fahrenheit. One is the boiling point, which is 212, and one is the freezing point, which is 32 degrees Fahrenheit. We know in Celsius or centigrade, 100 degrees is the boiling point, 0 degrees is the freezing point. So we have these two. Can we plot them in the graph? So we say the vertical line of our graph is the Fahrenheit, and then the horizontal line is our centigrade. So we just point the two. Here we have our boiling point where it crosses. We mark it with this red dot. And where the freezing point crosses, we mark with this red dot here. And we know the formula for, a general equation for linear relationship is Y equals to mx plus c. Sure, we can all remember this. So Y is the dependent variable. In this case, is our degrees in Fahrenheit. And then X is our independent variable, in this case, degrees Celsius. M is the slope. And then Y is the intercept. So what we're going to do is that we're going to pick those points that we've just noted. The freezing point and then the boiling point. We know what they are. It's 100 degrees centigrade, which is 212 Fahrenheit. 0 degrees for freezing point, which is 32 degrees Fahrenheit. And then we make the calculation. So our slope is going to be Y2 minus Y1. Let's just go back to where the graph is. Sorry. So we're going to subtract this value here, Y2 minus Y1. Then for the denominator, we use X1 minus X2. So here it is. And then when we put the values, this is what we get. And our slope is 1.8. Then we put it back in the equation. We still have C is an unknown. Y and X, we kind of know them from the values on the Y-axis and the X-axis. We know how to impute those ones. And then we just have to find C. So what we're going to do is we'll look for where one of them is 0. We already know that the freezing points X is 0. So and then our F is 32. We just impute those simple mathematical formulas I'm sure we used to do back then. And then we have this formula out, and this is a formula for converting from one domain to another domain. That's we're converting from the Fahrenheit domain to let's say from the X domain, which is the centigrade domain, to the Fahrenheit domain. And this is a form of an interactive web app I've done with all the values I've calculated. I'm just trying to show you what it's doable here. So we, in Europe here, I think, okay, no, not just in Europe. There was time we were working on some solar projects and we were trying to build solar water heaters. We had to put some valves that will cut off the water if it's above 40 degrees, because that would scald your skin. It's a bit too hot, anytime above 40 degrees. So we put that. That was why I chose 40 here to see what it is in Fahrenheit, which is here. So if I move it to the maximum here, that would be 100 degrees Fahrenheit, and then 212. We all know that. And we can see every other value in between. So I think this should be normal body temperature, right? 36 degrees. This is what it is in Fahrenheit. And then surprisingly, there's a point where two of them meet at the end. That's a minus 40. Sorry, somebody is raising their hand. Do I stop and listen to them, or do I just move on? Hello, can you all hear me?
Just go ahead with the presentation, sir.
Okay, thank you. All right.
Yes.
All right, thank you. So this is at minus 40 degrees centigrade. The value is the same thing as minus 40 degrees Fahrenheit. We have friends in Canada who say that during winter, the temperature gets as low as minus 40. And I'm like, okay, yeah, I remember this, but that's the point where the numbers are the same for centigrade and Fahrenheit. So that's just a simple explanation of statistics that we all know. And machine learning actually takes that to a higher level. Let me explain that by using something called multidimensional data, whereby it's not only 2 points. We're not just mapping from one domain to another domain. We're mapping from 2 domains maybe to 1 domain. So here we have features we have. Generally, this will be in an Excel sheet. You have the price of the house, you have the number of bedrooms, you have the size of the plot you're dealing with. So let's say you are looking for an apartment in Lagos, Abuja, Frankfurt, or Toronto. Generally, these are some things that might be considered into how expensive the price is. One area that I didn't include here is the area. Like you cannot expect a house in Morocco of blessed memory, to a house in, let's say, VI or Lekki. You know, no matter how big the house in Ojuelegba is, or what's the name of this other place, Oshodi. No matter how big it is, you cannot compare to a small Megad's house in Lekki. I didn't add that. I just wanted to illustrate something here. Just 2 extra dimensions. So if you want to plot it, to look for your line of best fit, this is already complex. So if the dimensions go beyond this, it's difficult for us to imagine. So mathematicians have tried to use formulas to calculate some of these things. The first one, where you just draw one line, it's a lot easier. We all did that in secondary school. But once you go to multi-dimensions, it gets a little bit more complicated. So that is where machine learning comes in to help us, because that can see multiple dimensions. You can compute that. And now with our graphical processing unit, things can even move a little bit faster. So when we're talking about machine learning, there's something else which some people consider a subset of machine learning. Some other people have different opinions of why. This one is called deep learning. What is deep learning? Deep learning is a kind of machine learning that uses a special kind of algorithm called a neural network, which is designed to mimic the way the human brain works. In machine learning, simpler algorithms often need humans to tell them what features to look for in data, like specific patterns or characteristics. Deep learning, on the other hand, can automatically discover these patterns by itself, thanks to its multiple layers of neurons. So let's show what a neuron is. Neurons are the basic units of a neural network, similar to how neurons work in the human brain. That is what I've been trying to mimic, even though some people think that the way the neurons work now have deviated from what psychologists and biologists know that the human brain works, but that was what influenced the design. A deep neural network has many layers of these neurons, which allows it to learn and understand complex patterns in large amounts of data, such as recognizing faces in pictures or understanding spoken words. This ability to learn directly from raw data with minimal human intervention sets deep learning apart from traditional machine learning. This is how, if you want to visualize what a neuron looks like, this is the smallest unit of a neural network. So here we are passing 2 features to it. Remember, the houses, the features, we had the price, we had the number of bedrooms, we had the lot size. Generally, the lot size and the number of rooms are the features we feed into the neural network for it to predict the Y, which is the price, which is what most customers will want anyway. You want to know how much this house costs. So if you're giving those two. But of course, like I said, if you want to really go deep into this, it's more than two features we're talking about multiple features. So of course, we'll have more than X1, X2, X3. It will go as the number of features go along. It can even go longer than that, which the next one will show us. This is how dense a deep neural net can be. Different layers here, they're called hidden layers. They're all here to do different things. Like, assuming you wanted to recognize my face, for instance, you have to have layers that would understand curves, some layers that understand colors, some layers that understand maybe triangles. And it's all these things that you bring together that will help you to recognize, give you an output. That might be a human eye. It can even go beyond a human eye. It can go into knowing whose eye it is. That's how good some of these neural nets can go. They can go into knowing which eye is this. Like I heard somewhere, I'm not an expert there, that zebras and all animals that have stripes and all that, that they all have unique stripes, just like our fingerprint. And you can train a neural net to recognize which zebra are we talking about over the other one. To me, they all look alike. Just like my fingerprints, they all look alike. I mean, I check my son's own. They look like they're the same, but according to scientists and experts in that, even the fingerprints of twins are not necessarily the same, which is quite, astounding to me. So now, when do you use each approach? I shared with you two different approaches. We have machine learning here. This is ideal for structured tabular data where traditional algorithms like regression, decision trees, and clustering can be effectively applied. So you're dealing with the tabular data, the kind of data you can supply to it from an Excel sheet. And then we have the deep learning here. This is best suited for complex tasks involving unstructured data, such as images, natural language processing, that's the way you speak, for it to predict the next word. Ricky is it can be anything. It can be he's a data scientist, it can be he's eloquent, or he's anything you want to just add. Can it predict that? And that is what we'll talk about large language models very soon, which has to do with what deep learning has brought to us now that we call AI. So large language models and then generative AI. Large language models, these are designed to understand and generate human language using deep learning architectures. The deep learning architecture we're talking about here is something called a transformer. I don't have the image here, but yeah, you can just look it up somewhere. It's a bit complicated. I just didn't want to bore us down with some details that you wouldn't need if you want to enjoy this. So what is the functionality? It's used for NLP tasks, and NLP here means natural language processing, such as text completion, translation, and summarization. These are examples of some of the architectures: GPT-3, BERT, and T5. GPT 3.5 is what we all know as Chat GPT. They just gave it a user-friendly name, which was nice because people kind of know that name. But all those things, they have one name you call them. It's large language models. They use something called a GPT technology. So an advanced form of GPT is GPT. There was GPT, then GPT-2, then GPT-3, then 3.5, GPT-4. We have 4.0. I think now is it 4.0? I think it's O for Omega. It came out a few months ago. Then I think just this week, they came out with GPT-4 Mini. It's supposed to replace all the GPT 3.5 because you can even do far more than the GPT 3.5. And for those of us who are querying the data using an API, querying that using an API, they give us cheaper tokens. So, and then we have BERT and all that. BERT, I think BERT is free on a site called Hugging Face. If you want more, I can share that with you. Then generative AI. Generative AI is to me, I think it's the same with large language models, but the difference is that this one does it across different media. You're generating different things. It can generate text, it can generate audio, it can generate images and even videos now. And that is where GPT 4.0, I think, is. The idea is that it is multi-modal, so it comes in different modes. So we have, okay, yeah, the first one was GANs. GANs is a different architecture, but I think now they are finding a way of merging them. And then we have OpenAI's DALL-E. We have there's Stability AI. They have different ones with videos and images. Thank you. So what I was thinking I would do is to share with us sorry. Let me just change my screen here. Okay. I'm showing a yellow screen. Is that what all of you are seeing? Sorry.
Yes, we are seeing
A yellow screen, right? All right.
Yes.
So okay,
Yeah.
thank you. This is let me try and get in. This is a Jupyter notebook online. It's called Colab. Google were magnanimous to give us this a few years ago. In 2018, it started becoming popular. I heard about it first in 2018. And if you don't have time to install all these things on your equipment, they give you this, is online. Even though some people are wondering if you wouldn't be able to, they won't be able to use your data for training, which is a big deal right now. And I just created this one here to just show you a few things. So I'm going to enlarge that. It looks small. And let me run that. If you know anything about Python, you don't have to worry yourself about this. I'm just trying to prove a point. This is what a data scientist would do. He would use Python. Python is the #1 language for now for data scientists, for machine learning, for AI. For some reason, it just picked up and people kind of, moved into Python. And in Python, you have different libraries. That means for geoscientists, I'm sure there are quite a number of libraries for geoscientists, depending on what you want to work on. But this is a general library just for anybody. Anybody can use the libraries I'm showing here. It doesn't have to be geoscientists alone. So these libraries are going to help me do what I want to do now. So here, the next page, I'm trying to generate random numbers. They don't make sense. These are random. You can see what's called random seed here. I'm just generating random numbers for various aspects, and I'm going to give them a name. I'm generating a number here for just a column 1, 2, 3, 4. It doesn't mean anything. I'm assigning that to something called well ID. I'm assuming I have a field that has different wells. So I'm giving them well 1, 2, 3. I'll skip some numbers, but it's a random number. I'll arrange them from a certain set to another set. I want to do that for 20 wells. And yeah, so this is the code to do that. And when I run this cell, it will just randomly create a data frame. A data frame is like an Excel sheet where you have data with different features in it. And these are some of the features here. The well ID, the X and Y coordinate, it could be latitude and longitude. I just picked X and Y. And then some depth, porosity here, some of these names. Let me see how it goes here. Okay, let me run this. So I'm doing this as somebody who's a layman here, but here just the data I collected. And I want to produce something like a contour map of the area. And I run that, and then it generates this for me. Like I said, this is random data. This is not a real location. I just created that. Now, this is what the process a data scientist would go through. So he would have to understand quite a number of these things, what he's doing, what the features are. This is the name of this feature. This is the name of, he has to know what X and Y is. That is why, as a data scientist, you will need somebody who has domain knowledge, somebody who knows the data that we're tackling. My sister is a nurse. She's doing her master's on some diseases like that, and she brought some of her data to me. So I had to sit down with her and say, okay, what is that? What does this mean? When these numbers are high, what do they mean? If they are low, does it make sense? The person who collected this data, did he make mistakes? If he made mistakes, then can you go back and get more, a better set of data, or get somebody else and stuff like that? So this is for geoscientists. And I'm sure many of you working in the field will know what this may say, but like I said, this is not real data. This is now, we all just did the generation together here. I'll share this with you if you want to play around with it. So, and then these are the libraries I'm going to use to draw this. And so let me reduce this. Now, why are we talking about machine learning here? I'm just going to reduce this. I won't show it. I would use my Windows snipping tool. I'm sure if you're using Mac, you have something else. I can just copy this. And then I hope you can still see my, good. So this is ChatGPT that we all know. This is 4.0. This is a mini asset that they released like a few days ago. So I want to paste that image here and ask it, what is this image used for? How can I interpret this? So let me just enter here. Let me see what it's going to tell us. Let me make it large so that we can all read what it says. So this image is a contour plot, which I believe it is, often used in fields such as geophysics, meteorology, oceanography, and engineering to represent three-dimensional data in 2 dimensions. Oh, I didn't know that. The contours represent lines of constant value, helping to visualize the gradient and topography of the data. So interpreting this, there are contour lines here, there are colors. The different colors represent different ranges of values. The color gradient helps to quickly identify areas of high and low values. All right, so let me just go back to the plot. Okay, I think I didn't plot, I'm supposed to plot the gradient by the side, which I failed to do. I could have done that. That would tell me, but I think from the pictures, we might be able to see, let me just enlarge that. On the pictures, we can see some numbers there. But like I said, these are not correct numbers. We just randomly generated them, right? So they may not make sense for now. But if you're looking for real life data, I'm sure we all know where to get some of those things. Let me check that. But then another thing I can do is I can go back here again. So let's assume you have an Excel sheet and you want to do your own analysis and you don't know all this machine learning I'm doing. You can just copy this. It's just real life, you just copy it. And by the way, the ChatGPT, you can, this is a paid version because I need to be calling the API for some other personal work, but you can connect to this without paying. So let me ask you, what data is this? So it's saying it appears to be related to well drilling. In fact, if I want to be nice to ChatGPT, I could just tell it what it is, right? So that it doesn't waste my time. So I can tell it, plot a contour map from this data. So it's going to analyze it. And then for those of you who are knowledgeable of computer, what do you call it, machine learning, you can actually verify because it's going to generate a code, usually a Python code. It will generate a Python code, and then you can actually bring it out, put it in Colab, and check. And with all these things, you don't need to install anything on your machine. You just need internet connection. So you can see its own. It's you can see the one it gave us. It even has this this legend by the side, so they can see. I think this one is porosity. It is concerned with. So you can see how porous the soil is. So it chose to create this. So you can see it even explains to us better than mine did, right? And if you want, let me see, where is it? Here. If you want the code, this is the code here. So you can just click here and copy the code and open your own Colab. Like I said, just Colab the research, open a new book. Let me enlarge that. Let's wait for it to. All right, let me enlarge that. I can just paste that. This is all the data I gave it. It just arranged it for me here, and I will just run this. Now, if you know a little bit about machine learning, you can like go through and see if it is doing something you're not sure you want it to do. There we go. And you can make whatever adjustments you want. This is a way you can also learn, assuming you want to improve on your skills. You can also be querying ChatGPT back and forth. Like I say, ChatGPT has a free version. There are others. This is Poe.com. Poe aggregates all the large language models that it can find. So you can query one and query another and query the next and see the one that gives you the best. There's one here called Claude. Claude is the one competing with GPT. You can see GPT Mini here. I've not paid for this one because I still prefer GPT. ChatGPT organizes itself. Itself for me. I like the way it does its things. Look at how it gives me the code, which you might not get on Poe. So these are some of the ways you can do that. So I wanted to just give this like an overview, and then I wanted to also use the rest of the time to see if some of you want to try out some other things based on your experience on the field. So this is when I say, okay, time for questions, as it were.
Thank you so much for your insightful presentation, Mr. Macharm. Please, if you have a question, please, can you just put your question in the question and here up so that later we'll take that. And maybe if I need to recap what you have, recap some of your pain points in this presentation before we go to the question and answer. You mentioned that machine learning is a hammer to chew things up. That thing caught my attention. It's like a hammer that chew things up. And you also see that if we apply machine learning, it allows us to accept different domains. And then also you say we have 3 types of machine learning: so supervised learning, unsupervised learning, and reinforcement learning. And you also mentioned that machine learning built on the principle of statistics. Then you use the example of linear regression, looking at the temperature using the freezing point. Also, you mentioned about deep learning, which you say is a subset of machine learning in AI that focuses on using neural network with many layers to model complex pattern in data. Also, you talk about deep learning architecture, LLMs. You say they are used for NLP tasks such as completion, transition, and summation. You give an example of GP3, BRT, and T5. Also, you talk briefly on generative AI, which you say is the techniques that create new content across various media, like emission of text, image, and video. And lastly, you demonstrate a machine learning and generating a contour map using a web data, which is very applauding using Python. I hope I recap correctly, or if there's anything I'm missing.
Yes, sir.
Okay, so thank you so much.
That's a good recap.
Yes, it has been a wonderful presentation and a lot of insight to us. Somebody close to me was asking a question that we are geologists. Why is this guy taking us to mathematician, to mathematics? And I told him, well, if you want to learn machine learning, because it's a glory team, you have to be able to understand data analytics, which is very key. And that is why we geoscientists, I believe, if we can introduce to our workflow in our data processing, assessment interpretation, well logging, it's going to help us a lot. It's going to save us a lot of time, and this human error will be out of it. So thank you so much for a wonderful presentation. Really appreciate that. So the first question I saw, and the question and chat is, explain hidden layer. Please, what is hidden? Please, can you just answer that? What is hidden?
Okay, let me try and get that out. Can you see my blue screen?
We can see.
Yes.
Okay. The hidden layer actually has some kind of activation functions. There are different activation functions, I call them ReLU. So it's more of math right now. So the idea is that, okay, if you remember our equation, let me just go back to, let me look for that equation. This is the equation we're talking about. This one, the y equals to mx plus c. The reason why I brought this math is, number one, I know every geologist here must have done some form of math from secondary school down to university. So I brought the simplest one so that you'll be able to remember and connect, then go back. If you want to go deeper into the math, but if you don't need to, like I said, we have, the AI is making it easier for us to just do our jobs without going back into the nitty-gritty of the math. So we have what we call y equals mx plus c here. We know that formula right from secondary school. Now, this is just for one dimension. You know, you're moving from one dimension to one. That's why it's like that. If it's more dimensions, you see x1 plus x2. So it's going to be m1 x1 plus m2 x2. If it's more than that, it keeps going like that, right? To infinity. For as many, this is something we humans can't visualize. The mathematicians who spend their time to make all those calculations, God bless their soul, they are very intelligent. We have the computer to do that for us. That's why I had to bring us from that beginning where I felt all of us would connect to. So in machine learning, they changed the convention whereby that M you're seeing, the so-called slope we're calculating, it's called weight. So it's W that they use right now. So, or some people use beta. That's the letter beta, the Greek letter beta. I don't have them here, sorry. I didn't think anybody would ask me deep mathematical questions, but it's good that you're asking. So all these calculations we're doing, you can see how long it took us. It's also simple. So imagine doing that for this. So across here, on this line here, can I increase this size? Let me see where. Is it increasing? It refused to increase. So across this line, this is the line here. From the input layer to the hidden layer. These hidden layers are there to help to adjust the weights. This is like the slope that we calculated. So because the idea is that, okay, especially if you're doing something called supervised learning, whereby you have answers here, you want to see if by using your contour map, let me use that, can you get the depth of the region you're dealing with? I'm using as an example. It may not be what you people do in your field. So you have the real depth and all the other data, right? So those are the dimensions that you are using to predict the depth, right? Just like you're using the location of the house, the number of rooms, the size, and all that to predict the price of the house. It could be the same for your geological data. So you want to see if you can, the insights the computer can get from all those variables you're giving it can help to predict, or let's say the output of the oil you may get. If it can give you the output of the oil you can drill out. So you have those data points you've been collecting. We need at least, somebody said 3 years of data, and I think they said 30 wells. If you can have those data coming from the same points, you have at least 30 wells that have 3 years of data. That would help you to predict the output of different wells. That was what a geoscientist from America was saying. So assuming you have that data, it needs to compare the features you give it, the porosity, everything, the longitude and latitude, everything, to the output of the well. But it will be making mistakes. It is trying to learn. So it will have to check, compare with what you give it, then go back and readjust its calculations. So it is this weights it will be readjusted. So this is one node that could be the hidden layer. There are some functions there called activation functions. We have ReLU, we have like 4 or 5 that we use. So it depends on which one is better. So me as a scientist now, if I'm working on this, I will have to change the activation functions because they will be the ones that will help us pass in all the mathematical formulas we've gotten here into all these ranges out here, compare with what we have, then go back using a method called back propagation. It will go back and change the weights of all of these nodes here, all the weights, and the ReLU is going to help us. Then we go back again until you get the one that has the smallest error. In real life, you never get it 100%. For the Fahrenheit to centigrade, we got it 100% because that's just a simple thing, right? It was just so simple. I mean, we didn't even need machine learning to predict that. We knew that formula from secondary school. I saw somebody putting the formula in the chat because my mathematical set in the 80s, I had the formulas for everything. I had the formulas and even, the speed of light. We had those details before machine learning could give us. But here I'm just showing you, okay, this is where we came from, and this is where we have arrived at. So that's what the hidden layers are doing. They're helping us to put the correct weights, going back and forth until you either minimize the errors you're getting, because sometimes people measure errors, or we increase the accuracy.
Thank you, sir. Because of we have too many questions, so
yeah, okay.
Maybe I think the next one on the chat box, I agree with no, not that one. When using on the OpenAI API to interpret geodata, will it with output be more accurate than detailed compared to the LLMs? I think this was I don't know, send this. When using the OpenAI. Okay, I don't know who said this. Explain better, exactly.
Yes.
The name is not there.
For me, I think okay, what does it mean by LLMs? I can't even see the question.
Okay, maybe while we wait for him, let's go to the next one because of our time. This one say, my question border around the ambiguity we have associated with processing and interpreting electrical resistive data. A single rock type has no unique resistivity value and also overlap with other rocks type. Therefore, performing prediction and classification is a problem because of the absence of the threshold of unique value. How do you think we can overcome this challenge and develop model to help with this ambiguity problem? You get the question right?
Yes, but like I said, I'm not an expert. I'm not a true scientist. So one of the things I would do is I will have to check the literature. How have people been tackling these problems in the past? What have they used? Machine learning is going to just make it faster. And then it can also help when you don't know the nitty-gritty. Like assuming, like if you can see my yellow screen, you don't know how to do all this I'm doing here. I did it by hand, then went back and met ChatGPT to help me do it itself, and even to help me to interpret. Right? And then they always warn you somewhere here that it doesn't tell you the correct answers all the time. So you have to always go and verify. It's not a tool to make you lazy, but for me, it gives me an edge whereby the mental stress I would have if I don't understand, it would ease it for me. Then I can quickly go and check. Because one thing it can do, it can summarize data for me. Like if I'm going to upload, I hope you can still see my screen. This is somebody who is using machine learning for something called smart proxy modeling. I don't know anything about that, but assuming you knew something, I can just tell it to summarize what was said and by whom. It will just go through it, read it, and then bring out a summary. But I think as an individual, I will have to go through it myself to be sure. It kind of reduces my stress, right? But it doesn't stop me from still doing the work. But if you can reduce a layer of difficulty, this might make your work a little bit easier. By the time the day ends, and you might be able to have seen that you have made some progress in some things that may be difficult for you. So that's what AI is doing, is a tool, like I said. So this is okay, it didn't give the correct name. At least I know now. When I played around with it, it gave me the correct name, but now it didn't give the correct name here. It just said Dr. Sharp. So maybe it didn't pick some words. By the way, you can do that on any YouTube. Let me see. Oil rigs. Let me just write on oil rigs. So that's who we are. We're geoscientists. You can just check. You can just check somewhere here, and you will see the transcript here. And the transcript is by the left. You can toggle the timestamps and just copy everything that was said. So if it is something you want, sometimes somebody was talking about formulas, and somebody was talking about formulas, and ChatGPT wrote out the formulas for me because I didn't know what the formulas were all about. So ChatGPT wrote out the formulas for me, and it was nice because I didn't know how to get the formulas. You can also take a screenshot and you just show it, and then ChatGPT will translate whatever I see. I hope that is that's okay.
Okay, thank you. One question here. It was not on the chart. Say, how do we as a geoscientists embrace machine learning? What do we need to do, especially for our students who are part of this technical meeting? What do they need to do to embrace this machine learning? Because they are not teaching this in school. Some schools are not teaching that we are geoscientists. What do they need to do so that we can embrace this machine learning? But when they leave school, at least they'll be marketable, they can get a job quickly.
There are courses online. Let me share one here. WQU.edu. This one is free. So they have a master's that's free if you want to include that, but that's in financial engineering. And then so if you can just go to WQ.edu, and you can click here to apply. You have to be 18 and above, which I think is okay. So this is one free course. If you have the time, a couple of hours a week, you can go through this one. That will just introduce you to machine learning. But for me, I think if you don't have the time, the data you are used to, you can just use ChatGPT. Like I said, you can use the free version, which you don't have to pay for. Just have an account and keep using it. You just have to know how to prompt quickly. That's all.
Okay, thank you. Thank you for my heart to the answer. I think what I will advise our young people, young geoscientists, they need more of collaboration and networking, If you have a friend who's expert in machine learning or data scientist, you can work with him and say how we can help you out. Also, like you mentioned, you have to learn the basics by starting fundamental machine learning, like I share with us. Also, we have to gain professional programming learning because geology alone now, the way we are going, I don't think will be enough for you, but you need something. But if we can integrate AI, like you mentioned, machine learning to our workflow, I think it's going to be fast. We are still going to be relevant. Because I remember somebody asked me, is it even necessary to go and study geology again in school? And I thought, yes, geology is still relevant. But what you need, all the skill that you need, that will add value to geoscientists, you just have to know it. So that when you go for any interview, you'll be on top. So please, I want to encourage you, like you mentioned, we need to attend learning, we need to develop our skill, not just what they teach you in class. You need to try and go out and ask questions, collaborate and network in a ask. Yes, what like you mentioned now, machine learning. How do I use machine learning to do my work? We are geoscientists. We have to think outside the box. Assessment interpretation, processing, even mineral exploration. You can use machine learning. So it's very, very critical to us. I don't think there's any other question. Chairman, are you still on Dr. Yunus?
Yes, sir. Yeah, I think because of time, I think we would take a break from question and answer. That would be okay for the day. Thank you so much, our speaker, and thank you also, Mr. Olani, for that nice coordination. We really appreciate you. Mr. Olani is actually a certified innovation professional and design thinking professional and a certified chief innovation officer and a member of NAPE, SPE, AAPG, and is a lead innovation in the research, lead head innovation and lead research at NNPC, RTI. Thank you so much, sir, for coordinating the question and answer section. And I want to also thank our speaker, Ricky, for that insightful, beautiful presentation. So we'd like to go to the next item on the agenda, which is award presentation. Okay. Are we all there? So I'd like to take a moment to extend our heartfelt gratitude to our distinguished speaker, Ricky, for this enlightening presentation. Your experts and insights have greatly enriched our understanding of this topic, machine learning. And to show appreciation to you today, we'd like to present to you this plaque. And it's actually our culture in the NAPE to present a token as to present plaque as a token of our thanks. Thank you so much. Your dedication and contribution to this field is truly inspiring. I want to thank you once again for sharing your knowledge with us. And this is actually an e-flag. We have the hard copy, we have the real flag for you for picking when you come to Nigeria, probably when you visit during Christmas, you can let us know so we'll send this flag to you. Thank you. Really appreciate you. Thanks for coming. And then
thank you.
We'll be waiting to give you this at your arrival in this country. Thanks a lot. And I want to also thank Mr. Olani. Thank you, sir, for the short notice and for responding so quickly when we asked you to come and share this occasion. Want to appreciate you, and we look forward to having you around at subsequent meetings.
Thank you, ma.
Okay.
Thank you, ma. You're welcome.
So you have an announcement from one of our executives, Mr. Guno, announcement of NAPE activities. Over to you, Emmanuel.
Okay, so I'll be taking that. Emmanuel is having a bit of a technical glitch with his computer. So it's Ibrahim. Ibrahim Don would take that. So Tunde, maybe you should do the projection. Okay, so in NAPE, it's a platform where you You have a lots and lots of resources for learning, for collaboration, and for networking. And what happened today is a typical example of what happens in NAPI, the place where you get educated beyond the classroom, beyond the university, beyond your workspace, because here is the broad knowledge base of experts, like we have seen today from our speaker, Ricky Macharm. Thank you so much for that. There will be other technical meetings from other chapters, Legos, as well as presentation. But on the slide here, it's worth noting to know that on the 10th to 14th of November, it's our annual international conference and exhibition. And the theme for this year's conference is Solving the Nigerian Energy Trilemma: Energy Security, Sustainability, Sustainable Growth, and Affordability. Now, this is one conference you don't want to miss. It's the largest, not just in Nigeria, but in entire West Africa. And then if you're into research, you want to present papers, there's a call for abstract right now. Please go to NAPIA website, all the different categories, and you have instructions on how to send in your abstracts for your research. Next slide, please. Okay. And then this is another flyer just talking about the different, you can present your advert. If you're an individual, a consultant, a company, a research institution, agencies of government or whatever, you can really take advantage and put in an advert in our bulletin, in our programs of events. It will give you the kind of outreach you want in your organization. Next slide, please. And there are prizes for that. This is not free, so you should know that there's a prize for each of those adverts. Next slide, please, Cindy. Now, in the exhibition hall, if you're into products and services, you can actually rent a space. Different sizes, different categories, based on your budget. And you can be able to meet with people at this conference and do your presentations, people that will be coming to the conference. Just like I said, he's the largest, he's the biggest. You want to cash into moments like this to be able to project yourself out there as an individual or as an organization. Next slide, please. Bayesian evaluation competition. This targeted to students, most times research fellows, feel have discovered something that the world of sciences or the world of sciences need to know. This is your opportunity. And then also you want to run back home with money in your pocket or some recognition and stuff. This is it. Don't hide it. Don't hide those research papers in your computers or in files. Bring them out. That may be your gateway in terms of your career. Next slide, please. Warri chapter will be having its technical meeting on Saturday, the 27th of July from 9 a.m. 4 p.m. And the topic for this training is right there on the flyer, professional development. It's targeting on how to develop yourself as a professional. Our president himself will be at this meeting. Vice president will be there. So please do well to join this technical meeting. See how you can enhance your career as a professional. Next slide, please. Okay, this is the same. We're calling for volunteers. In NAPI, you're not paid what you're doing. It's a volunteer service you do. So we're calling for volunteers in NAPI to be part of this Bayesian evaluation competition. All right, to serve as a mentor. I am one of those beneficiaries of mentorship in NAPI because somebody mentored me. So I am where I am now. So please, if you're already an expert in your own field of studies, do come, present yourself, and then you'll be attached to students, the younger professionals in the industry that you mentor and coach. That could be the best gift you could give to them, much more than any money. So please, professionals here that are listening, either via YouTube or on this Zoom call, please go on to NAPI website. There's a link where you could drop in your CV and NAPI Secretariat will contact you. Thank you. Next slide, Tunde.
Okay. Thank you very much, Mr. Dong.
Thank you,
Do
ma'am.
you have more adverts?
Yes, there's a couple
Announcement?
for registration, membership. I want to talk about membership, Tunde. Please go back to that slide on membership. It's important. NAPI activity happens because you and I pay our dues. So if you're here as a NAPI member and you're not up to date on your due, it's just 12,000 naira. For students, it's 2,000 naira. Associate member, 12,000 naira. And for corporate membership, 50,000 naira. These are monies we spend over lunch. But compared to the kind of knowledge we get in sessions like this. So please, if you're not up to date, click on that button on the website and make your payment. If you're having challenge, please call Abuja in the secretariat. We'll give you a direct link where you could make payments. And for those of you that want to be part of members, please be part of members. It will be one of the best investment in your career. All right? Thank you. Yeah, here's a slide. A number and is here, and account details that you can pay directly. So no excuse. And then do we have to have any slides? Okay, sponsorship. Technical meetings like this are being sponsored either by individuals or by organizations or by chapters. Like for this particular technical session, Abuja chapter paid for all the logistics, for everything that entails to hold us. And you can come in as an individual or as an organization and be part of this investment, okay, in the life of geoscience, in the geosciences world. Thank you so much for listening. Over to you, Dr. Eunice.
Thank you so much, Mr. Dong.
Thank you.
I'll be handing us over to right now to our Vice President, Mr. Ehibazwaye, to give us a vote of thanks. Mr. Ehi.
Thank you, Dr. Eunice. I also want to especially thank our speaker for today, Ricky. Ricky, you did a wonderful job. You didn't just come to give us a technical presentation, you actually came to give us a lecture. We want to appreciate this. It was in-depth. It was also very, very simple. You made it a really simple and affordable kind of presentation. We appreciate the depth you have brought into this presentation and also the simplicity. We really appreciate it. Thank you very much. We also want to appreciate our chairman of the occasion, Nee, for taking us all through. And most of all, we appreciate all of you who turned in, our fellows, our members, students, lecturers who came in, who turned into this presentation, and also for Abuja chapter for packaging this wonderful presentation. I want to say thank you and God bless you.
Thank you so much, VP. Closing remark, I'd like to thank everyone also for participating in today's insightful discussion, understanding machine learning for geosciences. And in this age of artificial intelligence, you will actually agree with me that it's actually a timely presentation. And like what Chairman said earlier, we should take this knowledge we just gained today and apply to all our ongoing projects to make us relevant, actually. And then ensuring that we stay at the forefront of technological advancement in geosciences. Actually, the world has gone AI, computerized these days, so we need really to key into it, not just learning the geology, but we need tools like AI, machine learning to actually be effective and to actually be productive even in our profession. Thank you so much, Mr. Ricky, for being here, for giving us so much this inspiring and insightful lecture today. We hope to see you.
Thank you for having me.
And I want to wish you great success in your career. Thank you so much.
Thank you.
And also to all our members, senior colleagues, I could see Dr. Bimbola Duroputon online. Thank you, sir, for coming. And also all our senior colleagues and fellows, and NAPE and members and student members Thanks for coming. So we look forward to having you around in our next meeting, which is coming up probably next month or in October, before our NAPE AGM. We'll actually publicize it and to everyone. Thank you so much for coming, and have a great day and a great weekend. Thanks. Thank you very much.
Just
Thank you, Doctor.
Before you
Thank
run,
you. Thank you.
if you're
Thank you.
on this call, can you put on your camera? Let me take a screenshot, please, of people in attendance. If you're on this call, put on your cameras. Let's do a screenshot of attendee, okay, please. And you need to give me your best smile.
Okay.
Tunde, you can do the same from your end, please. All right. So my daughter said, Dan, you're not giving you a best smile. So please give me a best smile. All right. Thank you. Have you gotten one too?
Thank you.
Oh, awesome.
Okay. Bye, everyone.
Thank you, ma'am.
See you next
Bye.
next meeting.
Bye.
Thank you.
Bye.
Thank you. Thank you.
Thanks for
Bye-bye.
coming. Yeah.
Ricky, thank you. Good job.
Thank you for having me.
All right.
Yeah.
Thank you. Bye, everybody.
Ima.
Mano, how are you?
Yeah.
I'm good,
Fine,
sir.
thank you.
Good afternoon, sir.
Nee, why don't stop that?
Ibrahim Doom.
Hi, Ima.
Mr. Ibrahim Doom.
Yes, sir. I greet you, sir.
Also Tiang.
Tianko.
So, Brandon,
Yes, ma'am.
calling your line.
Yeah.
I show.
I didn't want it to interrupt the internet. That's why, because the call was on already.
Okay.
All right.
Thank you.